Now that we've covered the shared responsibility model, let's move into another critical area of AWS security: governance and compliance. When organizations move to the cloud, security isn't just about firewalls or encryption. It's also about how the environment is managed, who can do what, and whether everything follows internal rules and external regulations. That's where governance and compliance come in. Let's start with governance. Governance refers to the policies, processes, and controls an organization puts in place to manage its AWS environment. The goal is to ensure that cloud usage is secure, cost-effective, well-organized, aligned with business and operational goals. For example, governance helps answer questions like: who is allowed to create AWS resources? Are teams following approved architectures? Are resources tagged properly for cost tracking? Are security standards applied consistently across accounts? In AWS, governance is often implemented using tools like IAM, AWS organizations, service control policies, SCPs, and resource tagging. These tools help organizations enforce rules automatically, instead of relying on manual checks. So governance is really about control and visibility, making sure the cloud environment doesn't grow in an uncontrolled or risky way. Next, let's talk about compliance. Compliance means meeting internal company policies and external regulatory requirements, such as HIPAA for healthcare, GDPR for data privacy, PCI DSS for payment card data, ISO and SOC standards for security and auditing. AWS helps here by providing a continuously audited infrastructure. AWS itself undergoes regular third-party audits and maintains certifications for many global compliance standards. However, and this is very important, compliance is still a shared responsibility. AWS ensures that its infrastructure meets these standards, but customers must ensure their workloads, configurations, and data usage are compliant. Think of AWS as giving you a compliant foundation, while you are responsible for how you build and operate on top of it. To help customers manage governance and compliance at scale, AWS provides several built-in services. Let's briefly introduce the key ones you'll see on the exam. AWS Config. This service continuously evaluates your AWS resource configurations. It can tell you if something becomes non-compliant, like an S3 bucket that suddenly allows public access or a security group that opens an unsafe port. AWS Security Hub. Security Hub acts as a central dashboard. It aggregates security findings from multiple AWS services and checks your environment against security standards and best practices. Amazon Guard Duty. Guard Duty focuses on threat detection. It continuously monitors activities such as API calls, network traffic, and account behavior to detect suspicious or malicious activity. Together, these services help organizations monitor, detect, and respond to security and compliance issues automatically, rather than relying on manual reviews. For the exam, and for real-world AWS usage, remember this. Governance is about control, structure, and alignment with business goals. Compliance is about meeting rules, regulations, and standards. AWS provides powerful tools, but customers must actively use and configure them correctly. In the next slides, we'll look at specific governance and compliance scenarios, including exam-style questions, so you can confidently recognize these concepts when they appear.
All right, so at this point, go ahead and pause the video. Take a moment to read the question carefully, and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
This question is about HIPAA compliance, specifically the Business Associate Addendum, BAA, which is required before running PHI, Protected Health Information, workloads on AWS. Before choosing an answer, focus on what the question is really asking. It's not asking how to configure security. It's not asking how to manage users or accounts. It's asking where a customer can review and formally accept a legal compliance agreement with AWS. That's your biggest clue. Here are the hints hidden in the question. HIPAA plus BA equals legal and compliance agreement. This immediately points to contracts and documentation, not technical services. Review and accept. Acceptance of agreements is done through an AWS console service for compliance documents, not IAM, config, or organizations. PHI workloads. Healthcare compliance in AWS always involves formal acceptance of compliance terms provided by AWS. AWS Artifact Agreements is the correct answer. AWS Artifact is the service where customers review AWS compliance reports and certifications. Accept legal agreements including HIPAA, Business Associate Addendum, BAA, GDPR-related agreements, other compliance-related terms. Before running PHI workloads, healthcare customers must log into AWS Artifact and explicitly accept the HIPAA BAS. This creates a formal, auditable agreement between the customer and AWS. Why the other options are incorrect. AWS, IMI, and manages identity and access, not legal agreements. AWS organizations used for account management and governance, not compliance contracts. AWS Config monitors resource configuration compliance, not legal or regulatory agreements. If the question mentions HIPAA PTI, SOIC ISO, or legal acceptance, I'm reviewing or accepting agreements. Compliance documentation. Think AWS Artifact first. This pattern appears frequently on the AWS exam. At this point, I recommend pausing the video for a moment and carefully reading through each of these benefits. They summarize why security in the cloud is fundamentally different from traditional on-premises environments. Now, let me briefly connect the dots. Cloud security on AWS is powerful because it scales automatically with your workloads. Security controls are applied by default as resources are created, so protection grows with your environment. AWS also removes the need for large upfront investments in security hardware, shifting costs to a flexible, pay-as-you-go model. On top of that, customers gain access to enterprise-grade security services and global expertise that would be extremely difficult to build in-house. Threats can be detected and responded to faster, often automatically, which dramatically reduces risk and downtime. AWS also simplifies compliance and auditing by maintaining global certifications and making audit reports easily available. And because AWS handles much of the heavy lifting, teams can focus more on innovation instead of managing security infrastructure. Finally, with built-in visibility and monitoring, organizations always know what's happening in their environments, helping them stay secure, compliant, and in control.
All right, so at this point, go ahead and pause the video. Take a moment to read the question carefully and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Now let's apply what we just learned with a quick question. Before choosing an answer, focus on what the organization is trying to achieve. They want to prepare for audits faster. They want to meet compliance requirements more easily. So ask yourself, which option reduces manual effort during audits? Which one aligns with AWS providing ready-to-use compliance documentation? Which answer reflects a cloud-native benefit, not an on-premises process? Remember from the previous slide. AWS simplifies compliance by maintaining certifications and making audit reports easily accessible, rather than requiring customers to build everything themselves. Correct answer is built-in automated compliance reports available through AWS Artifact. AWS maintains many globally recognized compliance certifications, such as SOC, PCI, DSS, and HIPAA, and makes the related audit reports available through AWS Artifact. This allows organizations to access compliance documentation instantly, speeding up audit preparation and meeting regulatory requirements without manual effort. Why the others are incorrect. Physical inspections of AWS data centers, customers don't perform these. AWS handles physical security. Manual review of logs from on-premises servers. This is slow and not a cloud security benefit. Continuously purchasing new compliance appliances, this increases cost and complexity instead of simplifying compliance. Exam tip. If the question mentions audits, certifications, or compliance reports, think AWS Artifact first. Now let's talk about where security-related logs are captured and stored in AWS, because visibility is one of the foundations of cloud security. One of the biggest advantages of AWS is that logging is built in. Many services automatically generate logs for you, and those logs can be centralized, stored long-term, and analyzed to understand exactly what's happening in your environment. Let's start with AWS CloudTrail. CloudTrail is the primary service for tracking account activity in AWS. Think of it as your who did what audit trail. It records every API call and user action, whether it came from the AWS Management Console, the CLI, an SDK, or another AWS service. So if someone creates an EC2 instance, deletes an S3 bucket, or changes an IAM policy, CloudTrail records who did it, when it happened, and from where. These logs are typically stored in Amazon S3, which makes them durable and ideal for long-term auditing and compliance. You can also view recent events directly in the CloudTrail console. Next, we have Amazon VPC flow logs. While CloudTrail focuses on account and API activity, VPC flow logs focus on network traffic. They capture metadata about traffic flowing into and out of network interfaces in your VPC. This includes information like source and destination IP addresses, ports, protocols, and whether traffic was accepted or rejected by security groups or network ACLs. Flow logs are extremely useful for troubleshooting connectivity issues, investigating suspicious network behavior, and validating firewall rules. These logs can be sent to CloudWatch logs, Amazon S3, or Kinesis Data Firehose for deeper analysis. Finally, let's look at Amazon's 3 access logs. These logs give you visibility into requests made to your S3 buckets. They record details such as the request type, like GET or PUT, the requester's IP address, the time of the request, and the identity making the request. S3 access logs are delivered to a designated S3 bucket, making them useful for security audits, access reviews, and forensic investigations. So the key takeaway here is this. AWS provides multiple layers of logging, each focused on a different aspect of security, account activity, network traffic, and data access. When used together, these services give you strong visibility, help you detect suspicious behavior quickly, and support auditing, compliance, and incident response in the cloud.
All right, so at this point, go ahead and pause the video. Take a moment to read the question carefully. and try to answer it on your own. Once you've made your choice, resume the video. Next, I'll walk you through a few clues to help you identify the correct answer.
Before choosing an answer, pay close attention to what the question is really asking. First clue. The question is about API activity in an AWS account. That means actions taken through the AWS console, CLI, SDKs, or other AWS services, not application logs or network traffic. Second clue. Notice the wording, who made each request and from where. This tells us we need identity information and source details, not just performance metrics or packet data. Third clue. Think about account-level visibility, not service-specific logs. The engineer wants a complete history of actions across the AWS account for the last 24 hours. Finally, eliminate services that focus on other areas. Some services are for monitoring performance. Some are for network traffic. Some are for security assessments. But only one service is designed specifically to record every AWS API call with full context. With those clues in mind, you should be able to identify the correct service. In the next slide, we'll reveal the answer and explain why it's the right choice. The correct answer is AWS CloudTrail. CloudTrail is the service specifically designed to record and track all API activity in an AWS account. It tells you who performed an action, what action was taken, when it happened, and from where. That's exactly what the security engineer in this question needs when reviewing account activity over the last 24 hours. Now, let's quickly look at why the other options are incorrect. Amazon CloudWatch logs is used to collect and monitor application and service logs, but it does not provide a complete history of AWS API calls across the account. Amazon VPC Flow Logs focuses on network traffic metadata, like IP addresses and ports. It doesn't track user actions or API requests. Amazon Inspector is a vulnerability assessment service. It helps identify security issues, but it does not record or audit API activity. So whenever a question mentions API calls, user actions, or account-level auditing, the answer you should immediately think of is AWS CloudTrail.
Thank you for watching. See you in the next class.